Sometimes, instead of just being given an inequality like x is greater than 10, you actually have to solve the inequality. So here we've seen 9 plus 4t is greater than 21. Well, looking at that, I don't know what the solutions are, so I need to get t by itself in order to determine the solutions. So this 9 is positive, so if I do a minus 9, that's 0, so I can move it to the other side. So I'm left with 4t is greater than 21 minus 9, which is 12. And then to get rid of the 4, we're just going to do our normal divide by 4, so that equals 1. Divide by 4, so we've got t is greater than 12. It's greater than 3, sorry. I'm just going to rewrite that. T is greater than 3. So what that tells me is that any value that's greater than 3 is a solution to this. So if I put it on a number line, we know it's a greater than sign, so it's an open dot. And then t is greater than 3. So I want numbers greater than 3. So any number that this arrow touches, so this is going to go all the way out to like 100. And 100 is greater than 3. So any number that this arrow touches, if I plug it into this equation, will make the inequality true. But any number not in the arrow is going to make the inequality false. So that's why these types of inequalities have multiple solutions. So same thing here, if I want to get x by itself, I would add 3 to both sides. So x is less than or equal to 13. So that's one way of looking at the solution. Let's see what happened there. Okay, 13, there we go. So x is less than or equal to 13. So that in itself is a solution, but you could also look at the solution on a number line. So we've got 13, a number smaller is 12, a number bigger is 14. So this time we would have a closed dot at 13 because of the equals to sign. So x is less than or equal to 13. So I'm wondering which of these numbers, if I plug it in, makes this true. If I plug in the 12, it's eating the 13, which is bigger, so 12 is the direction I want to go. So any number that this arrow touches is going to be a solution to this original inequality. The only difference between solving equations and solving inequalities that's really stark is dividing or multiplying by a negative. So when you multiply or divide by a negative number with inequalities, you're going to reverse the sign. So if I did divide by -2, what's going to happen is this inequality is going to go from greater than to less than. So make sure when you divide or multiply by a negative, you switch the direction of that sign in the middle. So here, if I was to multiply by 3 to get x by itself, this one sometimes trips people up. This 2 is negative, but the 2 isn't what I multiplied by. The 3 is. And 3 was positive, so we're actually not going to flip the inequality sign. So we can just leave it like this. Here, however, we are dividing by a negative number. So because I'm dividing by a negative, I'm going to switch the sign, which I just forgot to do. So instead of it being a less than, it's going to switch to a greater than or equal to -7. For the sake of keeping the video short, I'm not graphing each of these, but you would graph them the same way we've been practicing. Here we start it the same way we normally do, so we've added 7 to both sides. And then once again, we're dividing by a negative number. So because we've divided by a negative, we're going to flip the sign and get a -4. Finally, here we've got n divided by -3. So to get rid of the -3, I'm going to multiply by a -3 on both sides. So same as dividing by a negative, if you multiply by a negative, you also have to flip the sign. So n is now greater than 3. So all of your skills that you have for solving equations now used to solve inequalities, just remember if you're dividing or multiplying by a negative, make sure you flip the sign.